start the recording again. Tim and Janice just popped on. Before you guys go at the end, I did want to say for the Celestial this weekend at the Newport Pier, parking is challenging. It was packed when I went yesterday, so allot some time in your planning to find a parking spot and walk out to the pier. So we'll just meet at the end of the pier, but it was really crowded when I went yesterday.
Okay. All right, Mike.
Oh, nice. Okay. No parking necessary then. Let's get started. So this is our last lecture, if you could believe it or not. We're all celestial geniuses now, right? How much have we learned in the last 6 weeks, right? Oh, we've learned a lot. I hope so, at least. So today is all about prepping for our mostly stars. So I'm going to show you some examples of the sun running fix, but we're really going to focus on stars. The sun is kind of easy, if you will. No prep needed. You'll, depending on weather, always be able to spot the sun during daylight hours. Again, depending on weather. So let's dive into it. Any questions before we get started? You guys good? All right. So the sun fix is going to be a running fix. So the more time between our running fixes, the more separated our LOPs are going to be. This example is of a LOP at 0900 and then an LOP at 1400. And you can see they're almost 90 degrees. There's a, what is that, a 5-hour difference in between that? Yeah, 5 hours. So the change, that angle of the sun changed a lot and you got a good cross. So we want a minimum of an hour, but our hour fix is still going to be pretty close to each other. So the more time, if we have 2 hours in between or more, the better cross we're going to get. And going back to our coastal navigation class, our running fix is just a fix with LOPs at 2 or more different times. So they're an LOP, but at a different time. And how we make it a running fix is that we advance, meaning move an LOP along our track line or our DR line to the time of the second LOP. So this is just a simplified drawing of it. Boat speed was 5 knots at 090. So in 5 hours at 5 knots, they were going 25 nautical miles. So they just moved the LOP and kept the same angle, the same bearing line for it. And then with the LOP at 1400, wherever those cross is a running fix. So to make it more complicated, here's an example of mine. So I want to point out a couple different things on here. So, or basically explain what we're looking at. So down here, I have my 0100 fix. So that's a known position. And then I have my course and speed for the day. So I had an 0100, middle of the night fix, and then what my course and speed was doing for the entire day. Then I got a sun line, or I got a DR and a sun line at 0700. My sun line looked like this. At 0900, I had a little bit more of an angle. And then at 1100, I had a little bit more of an angle. So you could see how that line changes throughout the day because the sun is a different place in the sky. And we're moving too. So how I advanced this was just from 700 to 1100. How quickly am I moving? What is it? I somehow put 4.5 miles and advanced this 0700 line to here at 07 to 11. So I moved this line along my track line the 4 hours. I don't know where the 4.5 came in. And then I moved my 2 hours along my track line, and they all crossed exactly at my 1100. Now, we, on our practical example that we are doing, we are not moving at all, right? We're staying on the pier the whole time. So we don't have to do well, it's technically still a running fix. We don't have to advance or retard our lines because we are hove to or, not moving. We're in a stationary place. So we don't have to quite focus on that. But if you are, going to Hawaii or something and using celestial navigation, you'll want to move all your sun lines to one solid time. And most commonly, you're going to do it at a time that's easy to project out DRs from that point. So maybe you'll make your running fix always at noon or always at 0600 or always at 1800 or 1600, whatever your day looks like that that in your ETA calculations and things, you're always getting a fix at the same time. You could just advance, or that's why I say advance or retard. You're like, why would I ever retard a line? Because that's in the past. But that's just to get the fix at a solid time that that makes ETA's calculations easier. Again, this example here, I had a fix at exactly 7, exactly 9, and exactly 11, where typically you're like, oh, I get 11 o'clock fix. You might get it at, 10:58 or 11:02, or, it's not going to be that exact on the hour. So that's just, I guess, more reality of it. So there are 2 ways. Do I even want to go into this? I guess I will. Okay, but I'm not going to dive too into this. So here I have my 0700 line, and then I advanced it my certain distance along my track line and wrote and drew it in again. That's the most common way to do it because you already have your track line established. And if you draw in an LOP, usually it crosses the track line at some place. And so then you could DR it or advance it pretty easily. The other way is advancing your actual assumed position, the distance you would have traveled in that time. So my assumed position for 7 o'clock here, but I'm going to advance it along my track or in the direction of my track line 4 hours. So my assumed position is now there. And then I can, get my intercept and azimuth or ZN and intercept from my new assumed position, that it's here or here instead of actually on that latitude line. Again, this is the same thing. You're just making like a parallelogram essentially. So it's kind of more work this way because you're creating a new track line where your track line was already there usually. But I've seen it done both ways. I guess I learned how to do it this way, but I think the other way is easier. But again, we're not going to worry about that at this particular time because we are staying on the Newport Pier. But I know that's not realistic that you're actually going to be moving, most likely. Okay.
Yes. Question. So you're using the vertical scale to make that estimated mileage along your track line, or?
Correct. That okay. Vertical scale, so that's your latitude scale.
Right.
So latitude, 60 miles of latitude is 1 degree. So yes.
So even though you're kind of going at an angle, that's the scale you use. You wouldn't even get into the longitude scale.
You don't use the longitude scale for distance at all.
Yeah, that's right. Okay.
So the latitude scale, I would get my dividers out and measure the exact miles and then advance my line that way.
Yep, perfect, thanks.
Okay. So now we're going to talk about stars. That was my quick 2 slides on sun. But our main objective today is the planning and prep for stars. So does anyone have, not everyone, because probably not everyone, did anyone get the 249? Sorry, blurry. The 249 book? Or is, okay, so who's using the online version? Who has a hard copy?
I've got hard copy.
Hard copy. Okay. So we're going to dive into this today. Let me go back to the PowerPoint. Okay, so the 249 is what I use for predicting stars and which stars to shoot. It gives you a great idea or map or game plan to go for. Again, you don't have to use this. You could use a Rude Star Finder, but if you have 249, it makes life a lot easier. So up 249, it has, does this have, what's our latitude range on here? I think it has all of our latitudes, right? 89 north to 89 south. So we have all the latitudes. And then we also go in with our LHA of Aries. So our 249 is the only time we truly calculate our LHA of Aries. When we do star calculations, we do GHA of Aries and then apply SHA and longitude to get the LHA of the star. But going into 249 is really the only time that we do a full calculation of the LHA of Aries. So I just want to highlight that. I think I go into it. That we're talking about the LHA of Aries, not anything else. So the 2 things that they give us for each star is our HC, which is our altitude, and our ZN, which is our azimuth. So if we go back to this pretty little picture here, our azimuth is that ZN. So from north, where is this star bearing? And then the amplitude is how far off the horizon is it going to be. So this really gives us that direction when we're standing out on deck and looking for a star and you're like, I don't know where to look. It gives us a bearing and an altitude to kind of zone in on where we should be looking for a specific star. So it really gives us that direction. It has the altitude calculated, that's HC, and then our azimuth, that's ZN. We go to each page by latitude and by LHA of Aries. It gives us a spread of, how many is it? 1, 2, 3, 4, 5, 6, 7. 7 stars. So it gives us HC and ZN for 7 stars. So according to this, it is saying that these are the best 7 stars to shoot. Again, that gives you 7 LOPs, which is a lot. So then they kind of differentiate on this. They have a little diamond next to it, and the diamond means it's the best selection for a 3-star fix. So it has the best spread or angles for your LOPs. So the diamonds mean that it is they're suggesting as the best 3-star fix. If it's all capitals, it means that it is a first magnitude star. That means it's going to be bright. So your first magnitude is the brightest. So I'm going to apologize now. I cannot pronounce star names. I really am bad at it. I got there's Capella, but yeah. Schneider next to it is going to be dimmer. It's not going to be as bright as the Capella is. The Capella is going to be a first magnitude star. And we will see on a later slide with our star finder of the first, second, and third magnitudes and how we see the difference in what those are. Also, your Pub 249 is giving you the prediction for the best 3-star fix. It doesn't have any planets on it. It doesn't have any minor stars on it. So this is giving you out of the 157 navigational stars, these are the ones they're giving you. But of course you can do planets. Sometimes those are way easier to see than the stars. We'll go into how we can find those. So Pub 249 gives you a great selection of what you should shoot. After, or as we note which stars they should shoot, you always want to plan. So my plan is to note the altitude and the azimuth, and then also note anything else, what kind of constellation it's in, or if it's next to another one. I'm going to show you some slides later about some little rhyming phrases of how to find the correct star, if you will. That way you're more confident that you are looking at the correct star when you write it down. Again, if all we're writing down is the time and the altitude for each site. So if you write it down and you get something way off, you probably shot the wrong star, or said it was Capella where it really wasn't. So that is probably one of the most common ones. But if you follow my rules of thumb, you'll be able to shoot the right stars. Okay, so then I skipped over this first one, but to go into Pub 249, we want to calculate our DR for twilight or for star time. So that's AM twilight or PM twilight. We want to predict where we're going to be, so that way we can use that longitude to calculate our LHA. So remember LHA of Aries is going to be your GHA of Aries plus or minus longitude gives you your LHA. So the longitude that you want to use is going to be from the DR of star time, which is either AM or PM. So for us, in this next practical class, we're not moving, so we just use the same LHA. But when you're out there, you want to use a DR, so that way you have a better idea. So that's how we get our LHA. So the LHA is for star time. And then once we get the stars that we want to shoot, we take note the height and the bearing and anything else we want to come up with. Constellations, or in the western sky, in the eastern sky, which one am I going to shoot first? Any other notes that you want to take down. And I will show you my examples. This is from the Nautical Almanac. This is the constellations. So if you don't have, internet, or you can't Google, hey, what constellation is Capella in, or whatever it is, you can use the Nautical Almanac. They have these star charts, which are very rudimentary, but if you could find, the 2 things or the 3 things that you could find easily, like maybe I know where Scorpio is and Orion's belt. In relation, like, is some star going to be close to that, or to the right or to the left of that, that kind of thing. So you can use these charts to help you in that way. But I know a lot of you guys have the apps on your phone that'll tell you where they are too. But again, you might not have that underway. Okay, so the Pub 249 gives you HC and ZN of the 7 stars that it has. So when we do our predicting, we're going to write down all 7 because we're going to try to shoot as many as we can. So that's our Pub 249. Now I'm going to dive into the Rood Starfinder. So that is this guy. Does anybody have one of these?
No.
Okay, cool. So if you open it up, mine's pretty old, but if you open it up, you have a couple different components. You have a white card. So you have the northern hemisphere on one side and the southern hemisphere on the other. So you have north and south. We're going to focus on the north. And then you have the blue overlays. So the blue overlays have 2 sides. So let me get a different one on this one. So this one is 45 degrees south, or if you flip it over, it's 45 degrees north. So whatever hemisphere you're in, you want to be able to read whatever it tells, whatever it says. So again, this one, I can't really read the 45 degrees south. So, but I could read the 45 degrees north. I could put north on top of north and use this as my guide. And I'm going to dive into this more, but I just wanted to give you the components. So you have all of your latitude ones. They go by 10 degrees, I think. Yeah. So you have 5, 15, 25, 35, 45, etc. for all the blue overlays. And then you have the red overlay. And this is going to be for adding in planets or minor stars. So we can draw in the things that aren't on the 157 navigational stars. So those are 3 components of the Rood Star Finder. Now let's go back to the PowerPoint. I just keep saying 157. It's 57 navigational stars. So you can identify the azimuth and altitude. So again, we're identifying the ZN and HC for all of our navigational stars so that we can correctly identify which body we're observing. If you shoot a star and you have no idea what it is, you can note the azimuth and you are calculating the altitude, and then go back to the star finder to make sure, or to figure out which star you are looking at, so then you can find the correct SHA for it. So how do we use it? We need LHA of Aries. So again, we have LHA of Aries at star time. So we DR our star time and we apply our longitude to our GHA of Aries. No SHA involved, just GHA of Aries, longitude to get LHA of Aries. And we use our DR position. So those are the only things we need. So it's mostly our LHA of Aries, the DR position, we're ballparking, 10 degrees of latitude of where we are. So that's what we go in with. On the star finder, we have the first magnitude, second magnitude, and third magnitude. So that first magnitude star has a big bold circle and then kind of a bold white circle and then a dot. That's going to be the brightest star. So you just want to note, not all the brightest stars are going to be the easiest to see. Maybe a second or third magnitude is going to be easier for you to identify, but it's not going to be as bright. So when you're looking at the stars, you'll be able to tell, you won't be able to tell like, oh, that's a second magnitude. You can see that there's brighter ones and dimmer ones. So if you know you're looking for a third magnitude star, you're not looking for the brightest star out there. So you can see that on your star finder. And then you have the templates. So the templates, I wish I could zoom in more on this. You want to follow the curved lines. So it's sometimes not as easy as just looking at it. You have to follow the curved line. Like if we had a star right here, I'm going to follow this curved line and then read the number that, in this case it's both, but that I can read, 090. Of course I picked that one. Okay, let me follow this line. The number I can read is 040. So the backwards number is going to be for the south latitude or the latitude that I'm not looking for. So we always want to, the number that's easiest to read is the number we're going for. And then the circles is going to, and that's for azimuth. Excuse me, I didn't go over that. That's for finding the azimuth. The circles are for finding the altitude. So something is, the Polaris, the North Star, is going to be all the way on north here or at the top. No, altitude, that's your zenith. Excuse me, not Polaris. Don't know why I said that. Yes, so the cross here is essentially your zenith. And then this is your celestial horizon, not the celestial equator, the celestial horizon. For very low sites are going to be on the outer side of the circle, where your high sites are going to be on the inside of the circle. How to find this is you find your latitude ballpark within 10 degrees every 5. So you find the right blue overlay, and then you go in with the LHA of Aries. So that's going to be on the outer circle, and you put your 0 line on the LHA of Aries. So this is just an example from a different PowerPoint I had. We're in the south hemisphere. We have an LHA of, and it's too blurry to see, but we have an LHA of 279. We use the south base and then the south template 25 because our latitude was 25 degrees south. So we make sure those match, and then we put our LHA right where the LHA of Aries we calculated to be. So that was, what was that? That was 278.41. And then when we are observing our stars, let's see, we have Antares, and we can read that. It'll say Antares next to it. But in order to find what the HC and ZN are going to be, these circles are our altitude. So we follow the circle, and we have 060, this is 070, this is 080, this is 050. So about 60 degrees, maybe a little bit higher, maybe like 61 or 62. But ballpark 60 degrees for our altitude. For azimuth, we're going to follow this line all the way down, and we read the one that we can read. I know it's probably impossible to read both of these, but we get an azimuth of 260 true. So for each star, we can, so when you're looking at it, and you're like, oh, I want a good spread, I'll do one over here, and over here. If you're getting 2 stars next to each other, and they're in this very curved section, you still might get a 30-degree angle because of the way that the Starfinder is. It just has these curved lines. Okay, looking at the ballpark here, we have our celestial horizon. That's going to be the outside of that blue circle. So anything beyond that celestial horizon is below your horizon. So you won't be able to see any of these stars that are in the white area. You'll only be able to see the stars in the blue area. So that's your celestial horizon. Again, you can see they have the celestial equator marked on the white card, but you won't be able to see anything in the white area. Any questions so far? Okay.
Is there a desirable altitude? Like you don't want to pick something that's way too high or something that's, well, obviously if it's too close to the horizon, the twilight's going to mess with it, but is there like a reason to avoid something that's got a really high altitude?
You just have more refraction and more errors if it's high or low. So I would say somewhere between 30 and 60 might be altitude of 30 degrees to 60 degrees might be a good range to go for. But if you have,
okay,
but I don't want to say like stay strong on that, because I would say get as many sites as you can, and then when you're looking at it and you see like, oh, I have two stars that are at 70 degrees, maybe I won't do a full site reduction on those because they're really high altitudes. Maybe I'll do, a full site reduction on the others. If I don't get a good fix, then I could go back and get those ones that were at a high latitude and see if I get a better LOP. So
Okay.
I guess my strategy is go out there and shoot and write down as many as you can see, even if they're really low or really high. And then when you're back plotting, you can kind of say, oh, I want to go with, the 30 to 60 range and at least 30 degrees azimuth angle between them. But you can't go back in time, so just shoot as many as you can. Okay, so for the stars, or for the Starfinder, it doesn't have planets or minor stars. So how do we put in the planets and minor stars? We're going to draw them in. So I don't know what this white thing is made of, but if you draw it in with pencil, it's super easy to erase. So feel free to draw away. The two things that you need for the red card, you guys can't even see that, for the red card is going to be your declination and your right ascension. We haven't talked about right ascension yet. All right ascension is 360 degrees minus your SHA. So that's SHA of the planet, not GHA. So if we go to our, let me show you here. So this is I just flipped open to the, our navigational planets, Venus, Mars, Jupiter, and Saturn. They give us GHA and declination. So we're going to use the declination, and the declinations typically don't change a lot, but you could still do the, little D correction. But I mean, Jupiter here has the same declination for like a whole day. And your declination, you're drawing in with your pencil, so you're not going to have tenths of a minute accuracy with your pencil. So I just say a ballpark your declination here. And then down here is your SHA. So your SHA and meridian passage of each of the planets. So down at the bottom of your planet page, that's where your SHA is. So you do 360 minus your SHA, and that will give you your RA, or your right ascension. So let me go back. So for your RA, you're going to put down whatever you calculated your RA to be. So in this case, approximately 289-ish. Yeah, 289 was my RA. So I'm going to put that 0, and there's like a little slit in the overlay. That's where you're going to put the RA number. And then from declination, you have your 0, and that's going to be that celestial equator. So your declination is either south or north. So depending if you are on the north or south side of their card, you're going to go towards the center or away from the center. So we are going to do this for the planets for our predictions. But this was a picture of it. So I drew in, I had a, so for Jupiter, on August 23rd, our day of shooting, our SHA was 070. So our RA was 289, excuse me. So I have it at 289, and then my declination was about 2237. So I put it right at about 20, maybe a little bit further away, and that was south. 2237 south. So north is going to be towards the North Pole. South is going to be on the other side of the equator. Oops. So when I, so then I drew it in, and now I don't have to use my red overlay anymore. Now I go back to my blue overlay with my LHA of Aries, with my blue overlay, and I can see my, my J with my dot is right there. So if I look, I can see the altitude of this J is going to be about 25 degrees, maybe closer to 20. And then the azimuth is going to be, what is that, 150? So maybe 155 for the azimuth. So now I can see 155, about 25 degrees up. That one's going to be Jupiter, and it should be a very bright celestial body that I'm looking at. So, and you can see on the almanac exactly what magnitude it is if you are a dork about it like me. Does that make sense with your red and blue overlays? Okay. Again, we can do this together when we do our homework tonight. So this is my plan before start time. So I always like to go out there, whether it's going to be on the pier or on your boat, with a plan. So I use the 249 to get my 7 stars. So I have 7 lines, and I just draw in my azimuth. It's giving me a ZN, so I draw that in, and then I'll put the name of the star and the altitude so that I can visualize, because sometimes you're shooting where there isn't a compass and you don't know, like, where the heck is 155 or where the heck is 090? Like, I don't know where the compass is. But if you have what the ship's heading is, you can say, oh, okay, right off my port beam at 36 degrees altitude, I'm going to see Alcade. I'm bad at saying these things. And then also I write in next to it anything that will help me correctly identify it. In this case, it's part of the Big Dipper. So it's the end of the handle of the Big Dipper. So I kind of drew in the Big Dipper and I circled which one it is. I don't know all the constellations by heart, you know. So I draw in and I get all of this information straight from Pub 249. And I'll just draw in the azimuth, and then I write in the altitude. So then when I go out there, I can set my sextant to about 36.7, and then I could look around for that star. It should be generally right there. But again, maybe there's a cloud in the way or something where you can't see it. So this is one for an example of a boat, or if you were on a boat or a ship. The one on the right here is the one I did for our homework, or for our Newport Pier assignment. I put in an overlay of the pier and the shore, so I know I'm not going to be able to see a horizon on anything to the northeast. All of my stars and planets are going to be to the south. So I wrote them in with their approximate altitude. I know this is a bad scan. I wrote in my Jupiter and Saturn. And I also put over here, this is the bearing. I drew it in, but you can't see it. The bearing of the sun at sunset. So I know that I'm going to be able to see these stars. I'm going to be able to see Altair and Nuka, or Nuki, whatever that is, first, because they are further away from the sun. I'm going to be able to see the eastern skies first. So I'll probably shoot these, and then as the sun gets deeper and deeper past the horizon, I can shoot the rest of them. So you just go in armed with information so that you can, be successful. And this little chart thing is a Bree special. It is not a thing that a lot of other people teach. I've never seen anybody do it. But when I was teaching the cadets out at sea and they'd have their sea projects, I could teach them better if I had a little game plan or a map. So this is what I came up with. Again, it's not a technical thing that you're going to read about, but I think it makes life easier.
Hey, a quick question. To get the your sun azimuth, did you like do a reduction at sunset or something like that, or is that just it's kind of that way?
Yes, a sun reduction at sunset is called an amplitude, and
Okay.
that is a very great way to check your compass. That you can calculate where the sun is going to be, and it's technically 2/3 of the sun's diameter above the visible horizon when it's crossing the celestial horizon. But anyways, at sunset you can get an amplitude, and it's like cosine of amplitude equals sine over latitude over cosine of declination. It's a very short formula, and you can get the true bearing of it, and then you can compare that to your compass bearing and then get compass error.
Okay, so that's how you drew in on your diagram on the right.
That's how I drew it in. I did an amplitude. I calculated what the amplitude would be.
Okay, great, thank you.
Okay, so my next couple of slides are my my short little presentation on constellations for the celestial class. These are my go-to ones that are quickly identifiable for me, at least. I know everyone has their own rules or ways to look at the sky. So Orion's Belt, that one's pretty easily spottable for me, at least, in the sky. So the navigation stars that are in relation to Orion's Belt is they're pointer stars to Sirius. And then you'll also get Betelgeuse and Rigel. So Betelgeuse is going to be on the top of the belt, depending on where the belt is in the sky, right? And then Rigel is going to be at the bottom of the belt. So just a good visual to picture with your 57 navigational stars. You got 3 from Orion, and Orion's kind of a great one to spot. And then you have the Big Dipper. That one's, great to spot out there. The Big Dipper, the end is that Alkaid, and then the tip or the top of the cup is the Doobie. Those ones I feel like we come across to shoot a lot, depending on, where they are. But those two are great ones to shoot because they are those navigational stars, right? So even if it doesn't say on Pub 249 to shoot it says to shoot Alkaid and not Doobie, you know that that one's Doobie, go ahead and shoot it. Because you know which star it is. Even if you didn't write in, you know, the azimuth and altitude of it. Okay, Polaris, the end of the Little Dipper, but our pointer stars of the Big Dipper point to Polaris. And again, we can get latitude by Polaris, and that is a great quick way to go. So hopefully we'll on both of our, all four of our shooting days, we can get a latitude at LAN and a latitude at Polaris on the star days. So we're hoping to get both of those. And Polaris is going to be the tail end of the Little Dipper, and the Big Dipper points to it. Scorpio is sometimes easy to spot, and the big one that we see in Scorpio is it has the tail, and then it has the three things that go out, and right where those three things go out is Antares. Excuse me. And Antares is one of those stars that we end up shooting a lot for, that comes up in our Pub 249. So I always like to find that constellation. And this one I go for a lot too, that the Big Dipper, so Big Dipper again, the pointer stars point to the Polaris, and then the handle or the arc arcs to Arcturus. I can't say these words. Arc to Arcturus. Arcturus is another one of our navigational stars. So great ones to look at.
Is Arcturus being shown red because the star actually is red?
I don't think so. It's just a bolded thing there for you.
Oh, okay. Because I know some stars have a little bit of color to them.
Red tint, yeah.
Okay.
So those are, you know, some of the rhymes or the things to keep in the back of your head. And if you're doing your prep, write them out next to the star that you are going to shoot. So daily habits of the celestial navigator. You'll always want to calculate twilight. So that's morning twilight, evening twilight, whatever it is, to prepare for your shoot, your sun fix or your star fixes, because we use those LHAs. So we want to calculate what twilight is and then DR to both the AM and PM twilight, so we can get a correct LHA of Aries for each of those times. You want to plan on shooting either morning stars or evening stars. You don't have to be out there all day long with your sextant, but you have the windows of opportunity are, you know, sun during the day, and then you have a horizon and stars at morning and a horizon and stars at evening. So then you're, whatever it is, 10, 12 hours of darkness where you don't have a horizon, you can't do any shooting. So you want to maximize your shooting when you have a horizon, whether that's horizon in the morning with stars, horizon during the day with the sun, or horizon at night with the stars again. So if you're ambitious, you could plan on taking AM, so that's morning stars. Either do morning or evening stars. And then for the sun, you could either focus on doing an AM sun fix, a noon fix, or a PM sun fix. So that's just, or you could spread it all out. So maybe once every hour in the morning, once around noon, and then once in the evening. But if you do one in, 9 o'clock, one at noon, and one at 1400, you'll have a better spread on your LOPs. So it's all kind of up to you. Maybe you know that the clouds are going to come in the afternoon, so you get all of your fixes in the morning. Or you get the, morning fog in and everything clears up by the afternoon, so you only get a PM sun fix. Anyways, and then you also want to take an azimuth or amplitude once a day to keep a record of your compass error. So that step right there is the daily celestial that we do in the commercial, on commercial vessels. So we don't often take a fix by sextant. I can't say I ever did a sextant fix for the purpose of getting a fix. I did lots of sextant fixings with students, but not for like actual navigating. But we did take azimuth or amplitude every day, and that is to check your compass error. We don't go into that in this class, but maybe another class. For long passages, it's common to only plot a noon fix each day, or a midnight fix, or whatever it is, because when you're plotting on your chart, the distance between your noon fixes is only going to be like this much if you're going 10 knots on a very small scale chart. So you can't fit in a bunch of fixes in between. So it's common to just do a noon fix. And so you'll want to plan your celestial around that noon fix. Or you could do it, 1800 every day if you want to do evening stars or whatever it is. And then the big one is get the forecast. All of this is weather dependent. The two things you need to see are the horizon and the celestial body itself. So if you can see the horizon, but it's crazy cloudy and you can't see the sun, you can't get a sun fix or a sun line. So you want a horizon and the celestial body. So get the forecast, and that can help you say, oh, I'm going to get a PM fix, or I'm going to do morning stars because it's going to be raining by the evening, or whatever it is. So all of this is weather dependent. Any questions on that? Does that make sense? Okay. So for us, for our sun fix, our sun running fix, we won't have to do the advancing and retarding, but because we're staying in one spot, but it is technically a running fix because our LOPs are at different times. Our goal is to get one an hour or so before LAN, to get latitude by LAN, and then to get one an hour or so after LAN. Again, you can get many in between. You can get much later or much earlier, whatever you want. And you don't have to be out there for 3 hours or 4 hours with me. You can get your shot and then, go to the car in the AC for a minute, or go shopping, or whatever you want to do. But I will be there. So this Friday and this Saturday, 11:30 to 1400. So after you get, as many sun lines as you want, you can try and go for it to complete your site reductions at home. But then on Monday, we'll do a Zoom meeting like this, and we'll do it at 1800. So typically we're starting this class at 6:30. Monday, we're going to do it at 6. So note that difference.
It says
Friday and Saturday, 8, 14, and 16. So Friday's the 14th.
Oh, it's Sunday,
Oh,
not Saturday.
Sunday. Okay.
Sunday. I'm teaching a different class on Saturday.
Okay.
It is the 14th and the 16th. I'm sorry. That's confusing. Yeah, Friday and Sunday. I'm doing a different one on Saturday. And make note, we have a new Zoom meeting ID or link. So the link is on the Google Classroom. Let me know if you need it emailed to you, but this email meeting is, I don't know, I couldn't add another one to it. For the star fix, the sunset is about 1930. And we have to wait for the sun to set a little bit more for the stars to come out. So it might not even be shooting until like, 1945, 8 or 2000. But I'm going to be there at 7. I'm going to be there at 7 or 1900. Parking into your time here. So I'll be out there, shoot as many stars as you can. I'll try to help you correctly identify them. And then we'll do the site reduction and plot LOPs. So I will work through both of the sunline and the star fix on the Zoom meetings. So that's the game plan for the rest of class, really. Things that I didn't cover in this class, and these are just celestial things in general. So in case, like, hey, wait, I took celestial, but we didn't cover that. This is my waiver. Especially if you're getting the celestial endorsement on your license. These are things that are on the celestial exam that I didn't cover. You had the azimuths and amplitudes. Those are for finding compass error. And you can get an azimuth or amplitude of the sun, the moon, the planet, the stars. Typically, it's really hard to get an amplitude of anything but the moon or the sun. But azimuth, you can get an azimuth of anything pretty easily. Salines are calculations mainly for ETAs. And so I don't know if anyone remembers from my Coastal Nav 1, we had Great Circle versus Drumline, where a Great Circle track is the shortest possible distance, which ends up being this curved line on a Mercator projection, or you are constantly having to change course. It's like what the airplanes do. They fly up to Alaska and then come down to LA from Hawaii. So that's that Great Circle. So you have Great Circle, plain sailings, drumline sailings, just different ways of calculating basically like spherical trig of like where's point A to point B, how do I calculate all the different ways to get to those two places. So those are just like formula things in Bowditch that you can look up. ETAs, those are just your standard ETA calculations, but if you're taking a Coast Guard exam, the ETA questions are more, over days and longer crossings, where you'll probably have to do a sailing calculation in there to see how long it would take to get from point A to point B. The time tick. I don't know if we went over the beginnings of time tick in this class, but that is that exact GMT time where we have our chronometer and our chronometer error. Our chronometer error is correcting to this exact GMT time, and we use the time tick to get that chronometer error. again, we're not really good doing that practically, but if you're taking the Coast Guard exam, you'd practice calculating the chronometer error by using a time. Planet and ID on the Starfinder, I did briefly go over that, so I guess I don't have to put it on there, but I just went over it a little bit. And then azimuth of Polaris. So if you guys saw on your Polaris, our special Polaris table at the end of the almanac, we had the first 3 sections were for latitude by Polaris, and the very bottom section was an azimuth of Polaris. So that's a quick and easy way to get an azimuth, where the other azimuth calculations are a little more involved, like everything. But those are the things I didn't get to cover. But I think we covered a lot. I think we covered a whole lot. This was an example of the compass error book. You can just look that up online if you want. But that's all I got for new information. How are you guys feeling? Well, let's take a 15-minute break here. Come back at 8, and we'll dive into prepping and doing the homework.
Okay.
So, yeah, see you in a few. Texts are recorded. Okay, so we got the 22nd and we got our DR. We're hove to, so we don't have to put anything in there. Time of civil twilight. So we are going to do the PM civil twilight. We're not going to get the, maybe if we got there at sunrise, there'd be less of a parking problem. But anyways, we're going to do because then, anyways, we're doing the PM one. So we need to figure out civil twilight on the 22nd. Okay, so I have August 22nd, 23rd, and 24th. So this is going to be the same for all 3 days. This top half is our AMs. Bottom half of this section is our PMs. So we are going for civil twilight. So I'm going to go in, we have a DR latitude of 33 degrees. So we are going to be in between the 30 and the 35. So that's going to be these guys right here. So that's the 30 and 35. So I'm going to write that out. Okay, so my latitude is 33 degrees, 36, we're just gonna call it 36 minutes north. So what time is my sunset? And we use the back of the almanac on the latitude interpolating tables for sunrise and sunset. Moonrise, etc. So on this, we have 5 degree as our tabular interval. To our lower, our less latitude, we have 3 degrees, 36 minutes. And our time interval here, we have 3, 4, we have 7 minutes. So when we go into our table, we have a tabular difference of 5. So we're in this middle column. And then we are at 3 degrees 36. So I would say under the 30. So we're going to follow this line across, and our time difference is 7. So we are right in between this 3 and this 7. So you go with the 3, maybe it might go with 4, because at 36, it might be a little bit more. I think I'm just going to go with 5. Again, this is just 1 minute, so hopefully you're out there before this. But I'm going to go with 5 minutes. Does everyone get how I kind of mentally interpolated that?
Yes.
Okay, so if I have 1857 down here, and I have a 5-minute difference, that leaves me with a civil twilight of 1902. So, I guess I'll keep this on the page here. My, this is going to happen on my central meridian at 1902. What is my central meridian? We just did it before. It was 105 degrees west, right? So this is going to happen at 105 at 1902. With me so far? We are all the way over here at 117. 55.9. And we already figured out what our DLO arc to time is. What was it?
5144.
5144. So I'll go with the earlier one. I'll just make it 51 because I'm on this side of the central meridian. So 12, this happens at 9:02. 51 minutes later, it's going to pass my meridian at 1953. So that is my civil twilight. So I go back to this page. I'll say my time of civil twilight is 1953. So now my next step is to calculate my LHA of Aries. So I'm going to do that for my zone time of 1953. I'm using a zone description of -7. What will GMT time be when the sun is setting in Newport?
That's not +7 the next day?
+7, yeah. plus 7. Why am I having a mental? No, yeah, this is right. Okay. So we have 19.
So 0200
plus 7 is 26. So that minus 24 gives us 0253, and that's going to be on the 23rd. So that's our GMT time.
Accounting
Yeah.
for the daylight savings time?
So we accounted for our daylight savings time in this calculation. So the sun, instead of using 120
Oh, yeah, I get it.
as our central
Because
meridian, is the plus 8.
Yeah,
We use the 105 because we're at plus 7.
okay, got it.
Okay, so GHA varies. On the 23rd, so we have the 22nd, 23rd at 02. Our GHA of Aries is 1 degree, 49.6. What did I say? 40? So that's our GHA of Aries. We have to go to our minutes and seconds. We don't have seconds, but that's okay. So 53 minutes. So we're at 53 minutes and we're looking at the Aries column. So our Aries column is 13 degrees, 17.2 with our 53 minutes. So now we're going to add these up. So we have 49.6 plus 17.2 equals 06.8 and 15 degrees, 06.8 minutes. Then we are going to minus our longitude, and that's going to be 11755.9. So I have 66.8 minus 55.9 gives us 10.9. And 14 plus 360 minus 117. We have an LHA of 257. Are you guys good with that so far?
Yes.
Okay. So my Pub 249 info, because this is for planning purposes, I'm just gonna round. I'm gonna say my LHA of Aries is 257 and my latitude is 34 degrees north. Just so those are some even numbers that I could go into Pub 249 with. So you could bring it up on the pub, on your electronic pub on your computer, or you could get it by hand. We are going to find, and we go in by finding our latitude. So we're going to look for 34 north. Okay, so here is my spread of 34 north. What are we using? So on this side, we have our LHA of Aries, 0 to 89. Then we have 90 to 179, 180 to 269, and 270 to 360. So this whole spread is 34 degrees, and it's each 90 degrees of our possible LHAs. So we have an LHA of 257. So we are going to be on this side. We have 34 degrees north, and then we're going to 257, which is going to be down here at the bottom. I'm going to underline this. Zoom in for us. Okay, so this is telling us our 7 stars, and it tells us our HC and our ZN. So we have Deneb, Altair, Nuki, Antares, Arcturus, Alkid, and Kochab. I'm horrible at saying star names. So on our selected star worksheet, we're going to basically just copy this information in. So I'll copy it in the same order. This order is ordered by bearing. So you're kind of working your way around using it, and we'll see that in a second. So, so I'm just going to copy it straight in. Deneb, we have a ZN of 058, HC Okay. So I wrote in the information it gave me here, but then it also gave me information with the names. So it gave me 3 stars. It gave me what its idea of a great 3-star fix would be. Deneb, so I'm just going to put a star next to that, and Terry's, and Alta. So that's what it thinks the best spread will be, but maybe some of those are on land. I don't know yet. So we might have to come up with a different one. And then I might also make a little mark for the bright ones. So Altair, I'll just put a circle. You can do whatever symbols of Deneb you want for the bright ones. Antares, Arcturus, and those 2 are dimmer. So then here I also want to write in which constellations, or give me tips about where I'm going to find those. So let me go back to that. So not Orion. What do we have? Alcad, that's part of the Big Dipper. So I'll say Big Dipper, and these are just notes for yourself. Okay. Don't have one for Deneb. And Terry's, that's going to be part of Scorpio. And Arcturus, I'm going to say Arc to Arcturus. Okay. So I don't have a ton, but I wrote in a couple little notes. So what I didn't write in here was planets, which we're going to go into. But just with this information, let's draw out, I think I have our next page here, where they're going to be. So if we are on the end of the pier, where are these stars going to be? So using this information, we have Deneb at 058. So that would be here. So we are not going to be able to shoot that one because it is right on the land. I'm not even going to write that one. Altair is 115. Here's 110, 115. So I'll draw that line. And then I'm going to write the name and the altitude, 4510. So when I'm looking, oops, can't see that. When I'm looking for the stars out there, and I look, south along the coastline, and I put 4510, I should see somewhere around there as I'm moving my sextant around Altair, and it is a bright light, so or of first magnitude, so it's a bright star. I'm just going to continue around. Nunki is 154, so 154 right here. And that is 2439. And Terry's is 190. And that's 2853. think I'll also put Scorpio on that one. Arcturus is 260. And then we have 308. Okay, so I have drawn out the 7 stars that they told me to shoot. 2 of them I'm not going to be able to see. And one of those was the one that, can I show you both this? I'll just, so Deneb was one that it said would be great for our 3-star fix, but we're not even going to be able to see that. So maybe we should come up with what our 3-star fix is going to be. If you can see here, we have Alkaid and Altair are pretty reciprocal. So if we get both of those lines aren't going to cross very well. So this gives us a good visual of, and again, the lines that we get are not going to be this. It's going to be perpendicular to this line, but it gives us a good idea of the 3 things that we want. So I might say maybe Altair and Terry's and Arcturus might give us the best spread. I'd say those ones. Yeah, Antares, Arcturus, and Altair. So I might make a note that those ones I really want to get. If I had to skip a star because I couldn't see it, I really want to prioritize those 3 because I think they make a good spread, if you will. But if we can get all of them, get all of them. Does that make sense so far?
So I have a question.
Mm-hmm.
I got different numbers than you did for HC. What did I do wrong?
But you got the same bearing?
It's latitude 34, right?
Yep.
And 257 for the LHA.
Yep.
And my book says, maybe I have the wrong book. My book
You know
says,
what?
yes,
I think I probably have the wrong book.
I have volume 1.
Mine is very old, but I don't think it should change that much.
My book's older than yours, and my numbers are slightly different for the.
And yours are slightly different?
Yeah, by just a little tiny bit. So, but I think for this exercise, it seems to be working.
Yeah, you'll ballpark it either way, but
Okay, well, I just wanted to know why they were different, that's all, so. Oh, I see, you're 1980. Ah, okay.
Yeah,
I'm
mine's
1980.
mine's
Got it.
1975.
So yeah, if you get the one online, it should be the most up to date because it's from the website,
Okay,
the publishing website.
all right, that's all I was concerned with.
Yep.
That helps a lot. Thank you.
Yes, good question.
I'm looking at the one online, and I mean, it's just a few minutes, but it's definitely different.
Okay, yeah. So again, this is going to be, you know, ballpark-ish, but that's good to know. You want to use the latest one if you can. But if you have an old one, not a big deal. Okay, so now that we have our drawing, our next step is to add in the planets, because there will be planets out there and we want to know where those will be. So any questions on this part of the planning so far? Okay, so for planets, we are going to use the Starfinder. Let me get my pieces. They're all over my desk here. Okay. So to use the Starfinder, let me do blue. For the blue, all we need is our DR latitude, and that's within 10 degrees, so a very rough DR latitude, plus or minus 10 degrees. And then our LHA of Aries. For the red overlay, we need the right ascension and declination. So those are the things that we are finding. We already calculated LHA of Aries. So we can use what we already did. We don't have to redo it. LHA of Aries is 257, and our DR latitude is about 35. We can use the 35 north. So on your white card, find the side with the N. And then with your blue overlays, find the 35. So you would put all the other ones to the side. So you want your 35 north legible. So the other one is 35 south, but it's read backwards. So we want to keep it like this and put our white underneath it. So we have our N and our 35 north. So this is what it will look like. And our LHA of Aries, down at the bottom here, we want to move it to the 257. So we're going to move this, moving that along to our 257. Okay, so we aren't going into planets just yet. These are the stars. So if we look at, I wanted to zoom in, but I'm getting that reflection. The stars that we want to see, you can see we have Antares, Arcturus, Altair, Deneb. All the ones that we want to see are on our horizon. If there's a different one, like, Doobie, whatever it is part of the Big Dipper. And I know that, but I want to get what the azimuth and altitude is of it. I didn't have it on my Pub 249. I can follow this line. Here's my Doobie. Oops, you can't see it. If I follow the line, I'm reading 330. So the 210 is backwards. That wouldn't be the azimuth. The azimuth for this would be 330. And the altitude for Doobie would be 30. Here's 20 degrees, here's 30 degrees. So these is our celestial horizon at 0. So altitude goes 10, 20, 30, all the way up to our zenith. So yeah, our altitude would be about 30. It's going to be kind of low on the horizon. So that's how we see things on this. But the planets and the minor stars are not on it, so we need to add those. So, I'm gonna put in my planets. So I'm gonna go to the almanac. What day are we doing again? December, not December, I read December. August 02, August 23rd. Okay, so we have Venus, Mars, Jupiter, and Saturn. So I'm just gonna write in those. And the two things we need are RA and declination. So we have Venus, Mars, Jupiter, and Saturn. We need declination, SHA, to give us RA. So those are the two things that we need, our declination and our RA. I'm gonna make a little rough little chart here. Okay, so my declination so I go to 02 because that's my GMT time on the 23rd. My declination, I'm not gonna be able to do both of these, but I'll read it out to you. I'm gonna go with 0300 because my 0253 is so close to 0300. Okay, so I'm gonna go with a declination of 20 degrees, 0.9 north. For Mars, I have 6 degrees, 6.6 north. For Jupiter, I have 22 degrees, 36.6 south. Saturn, I have 21 degrees, 08.4 south. So those were my declinations. And again, you're writing in with your pencil, so you don't really have to do that little D correction and everything. It's a rough number. So SHA is going to be down at the bottom of the page. So we have SHA for each of the planets down at the bottom. So our SHA was 254, 07.3, 334, 26.4, 70, 19.8, 61, 30.9. Okay, and before I close my almanac, I'm just gonna write in the magnitude just as a mental note. So for Venus, I had minus 4.3, Mars minus 6, Jupiter minus 2.6, Saturn plus 0. Okay, that's floppy. Plus 0.3. Okay. Closing my almanac. So now to get RA, that's our right ascension, RA equals 360 minus our SHA. And if you have a newer Starfinder, it says that formula on the package. This one doesn't, but sometimes if you have that new plastic one, it says it right on the package, so you don't have to remember it. So I will do, I'm gonna round these numbers as well. So I'm gonna do 360 minus 254 gives me 106. 360 minus 334 gives me 026. Minus, I'll call it 61.5, gives me 298.5 degrees. Okay, whoops. So I'm going to quickly change. Okay. So now I have my information to go to plug into, so I don't need my SHA, but I have this information I could put in the draw. So, see if I could zoom in here. We're going to use the right overlay, and on the right overlay we have the same, it says north latitude or south latitude. We want to be on the side where we can read north latitude. We're back on the north white card. And our first one we're going to do is Venus. So Venus has an RA of 106. So I'm going to find, here's our 0 on the bottom here. We're going to find 106. Here's 106. Okay, so let me focus this here. So you can see the little carve out on the red overlay. And I have my 0 at about 106. And then with my pencil, I use my declination. So what was my declination for Venus? I'm covering it. Anybody write it down?
20 degrees 0.9 north.
North. So if this is 0, this direction is going to be north. Move this down here. So if it's north, this is the celestial equator. You can see it's a celestial equator. So if it's north, it's going to be on this side. So it was north 22 degrees. So
20 degrees.
20 degrees? Okay, so 20 degrees. I'm going to put a little dot, and I'm going to put a V next to it. So that's Venus. And I just wrote it in there. So now, my next one, what's my next one? Mars at 026 at 6 north. So 026. Here's 025, 026. So down here, the zeros at 026 on the white, and I'm at 6 north is my declination. So here's 0, and I'm going to go north towards the North Pole, and it goes by 2. So I have 2, 4, 6. I'll call that right there. And that was Mars. So that's a little M, if you will. So that's where my Mars will be at this specific time. And then next, we have 290 at 2230. Okay, so 290. Did I mess that up? 290. All right, so I'm at 290 here at the bottom. And it was at 22 south, right? So that's going to be away from the North Pole. So we're going to go 1022, right about here. I'm going to call that Jupiter. And then Saturn, I have 298.5 and 21. So 298 and 21. So very close to that Jupiter, we have Saturn. So that was my Jupiter and my Saturn. Now I have my Jupiter, Saturn, Mercury, and Venus on my, plotted on my celestial card. Then I go back with my north latitude 35, my blue overlay, and I find my LHA of Aries again. We're doing our LHA of Aries. And that was 257. So 257. So I have my arrow pointing to 257, which is my LHA of Aries. So everything within the blue circle is going to be visible. Anything on the white is not visible at this particular time because we're using LHA of Aries. That has to do with our time. So Venus is not going to be on the horizon, and neither is Mars. Mars is not going to be on our horizon, or not visible in the sky at this time. But we do have a Jupiter and a Saturn. Those are both here. So I want to take a note of what their calculated, their HC and their azimuth is. So for Jupiter, right on this line here, so I'm going to follow this line, and I'm going to call it 25. So I go back to my paper here, and so for planets, I have Jupiter is going to be 25, my HC is 25 degrees. And my ZN, so here's my Jupiter. I'm going to follow that line to the end of the circle here. And I have 150 and 140. So I'm going to call that 145. So that was my information for my Jupiter. For Saturn, it is going to be close here. So here's my dot for Saturn. I'm going to follow this one to see my HC is 20. And my ZN is good. Here's 130, here's 140, so 135. They're about 10 degrees apart from each other, pretty dang close. Now I also want to note their magnitude. So Jupiter was minus 2.6. I'm going to write in minus 2.6, and Saturn was plus 0.3. So which one's brighter?
Jupiter.
Jupiter. The negative number is going to be brighter. So if we see two planets real close to each other, I can say, hey, the brighter one is going to be Jupiter. So all that work with the Starfinder, we got two planets. But again, what we also got, I didn't write in, any other stars you want to take note of. 257. So maybe you can always identify, what did I say earlier? We can add in Doobie. Doobie was, what do I do? My azimuth was about 330 with an altitude of 30 degrees north. So any other stars you want to add in, maybe you're good at identifying one or the other, you can use the Starfinder. On this, our plan here, we can add in our Jupiter and our Saturn. Um, 135 and 145. So we have all very close together. But that will help us a lot when we are plotting or we are out there using it. I also had just a blank what do we call it, universal plotting sheet that you could use, just a blank one. This one I put the overlay of the chart on it so you know what you can't see. I drew in this one, as an example, I put my barriers at 100 and 340, and I just got that from my chart. I called it 340 and 310. And then I put in my numbers just so, and what I also do is use this and I write my information on it. So I'll put, you can do it, in a notepad or something, but I'll put like, oh, I think it was Alta, it was somewhere bearing over here. I got, 52, 55.3, whatever you actually got at, we'll say 1932.41. We'll put in the time and the altitude of what you actually got. And that way, if it turns out it wasn't this star, you saw it in this general direction on the north side of the pier or something, and that can help you find it on the star finder if you did a minor star or some other star. So that's why I like to write it in, I guess because I'm a visual person rather than in a notebook, but a lot of people just write it in a notebook. But that's all I got for you guys. Does anybody have any questions? Guys ready? We're ready to shoot?
Hey, Bree.
Yeah.
Talk me through, from the time the captain says, we're out here in the middle of nowhere, where the hell are we? Are we on course? Take me through the steps without doing the calculations. Just what do you set up and how long does it take you? If you're doing, on the ships that you've been on, you're doing 25, 30 knots. I'm on a sailboat doing 8 or 10 if I'm lucky. From the time you take and start all of this to where I can say, that's where I was, how long does that take somebody with your skill set to have all this done?
I would say if you could get your star fix done within an hour, then you're pretty good. It's going to take you guys a lot longer than that, so I don't want to say you should be done with this in an hour. But a lot of the stuff transfers over. So like when you get your GHA of Aries, it transfers to each star because you took it within 10 minutes of each other. So you kind of learn these shortcuts along the way, and that's why it's so individual for each navigator that what they use. But I think I want to say within an hour, within all the other things that you're doing up there too. Bridge management or whatever you want to call it. I think you can get it done within an hour. For a sunline, again, you want to plan your sunline for, noon or something like, an 8 o'clock one or a 1600 one or something like that. So those are running fixed lines, but you could always just put them on the chart and then, and that is something we didn't practice actually in this class, was plotting this on the chart. We were only using our universal plotting sheets, but you could plot it directly on the chart and see where you're at and how far away you are from what we know as our actual position. But definitely you could try that out. I don't know, does that answer your question? As like a second mate, which is the navigator on commercial vessels, they do the pre-planning. So they're going to be doing that prep, that, oh, this is the time of twilight. This is going to be my LH of Aries at twilight for AM and PM. This is my time of LAN. So that you're not out there, like when we're out there, you'll see it only takes, 5 minutes. You get your index error, shoot the sun, and then wait around for another hour. So you can, if you guys are ambitious, you can plot out your whole site reduction right there on the pier and then do another one. And then plot out the site reduction and do another one in an hour.
Yeah. For me, it's just, it takes you an hour. It take me 2.5 hours, 3 hours. And in 3 hours, I'm farther off course than I thought I was before. So now I've got to make some sort of tack and correction.
Yes.
And start over again, because now all of a sudden I'm not really where I thought I was. 3 hours.
Yes, and that is why we use GPS, or you can shortcut it by saying, oh, I'll use a celestial calculator. Well, if you're using a celestial calculator, you might as well use GPS, in my opinion. Right? You're using the electronic thing. So I think Celestial is a great backup that you can, be using your GPS or your chart plotter or something, and to hold your course, and then every day do a Celestial to say, hey, my course plotter or my whatever electronic navigation tool that I'm using is still accurate because I am proving it with the Celestial side of things. Or you can discover, that you're off or something.
Yeah, and that brings up the question of, if we're getting better at reducing these and taking these, what's a reasonable nautical mile variation between what a GPS might say and then what we can get with a sextant and with for a reasonable navigator?
I would say you want the tightest triangle possible. So
right.
But what will end up happening is that you'll get, a triangle. And if you can get a triangle, I'm going to say within, 10 miles, 15 miles maybe. You can go bigger than that. Then that's a good triangle, because you're typically in the middle of the ocean, right? If you're using Celestial, you have no aids to navigation around you. So if you're off, in typically your horizon, your visibility, you could see 10 miles. So if you're about 10 miles, give or take, I would say that's pretty good. That you're not, an island is right over the horizon. It's probably 10 miles away with visibility. But that's hard. It's hard, and we're going to practice it. So yeah.
I think the other thing that happens is, if you're doing the plotting every day, then what's going to happen is local apparent noon, you're going to get used to when that's happening. You probably won't have to calculate it every day, because
you start to see trends.
Do 2 or 3 of them in a row, you'll realize, okay, tomorrow, it'd be 6. So you plan you don't have to sit down and
you're breaking up a little bit there, Janice, but yeah, you start to see trends of where your numbers are going, and you're always on the same page, so there's less like flipping through all of these pages and all of these pubs, that you're just going back and forth to the same two pages, and it's the little shortcuts that start to get quicker.
Okay, that helps.
Yeah. It's not as bad as, it's not as scary as it is. Hopefully you guys feel like it's not as scary as it is after 6 weeks of me lecturing at you.
Yeah, it's just me thinking I'm on my way to Honolulu, and I'm now 43 days out, and the next island I see is Fiji, and go, what did I do wrong?
Yeah. I don't know, but let's see how how it goes this weekend and next weekend. It'll be fun. I'm looking forward to it.
All right, so what's the logistics on the pier? They have bathrooms there? Do they have places where you can get sandwiches? What's,
Oh, yeah.
Tim,
There's
you're an
definitely-
expert on the pier.
Yeah, well, I mean, I live 15 minutes away from it, so you know, it's with COVID, everything. I mean, the restaurant's pretty well shut down, but you can order stuff, but you can't sit down. There are public restrooms right at the pier, right at the lifeguard main station at the base of the pier. So,
Okay.
yeah, I mean, you can get anything you want to eat or drink. But again, COVID's definitely got impacts. You can't go sit down at Blackie's Bar and have a beer before we show up.
right?
There
Okay.
was a ton of like the outdoor, like the restaurants have moved their tables and stuff outdoor.
Yeah.
So yeah, when I went down there yesterday, it was busy. But I guess I was talking to my sister-in-law and she said all the beaches are busy. People are just at the beaches these days. So we will try to sneak our way in there.
Wear a mask.
Wear a mask, please. I'll be wearing a mask. I'm gonna bring my actual metal sextant and the OCC sextant. And I'll be there with, I'm gonna bring a little chair so I can sit in the shade.
Bring a hat and sunblock.
Bring a hat and sunblock. We'll be hanging out. So I'll be there Friday and Sunday, not Saturday like my PowerPoint said.
And
I'm
then,
doing a Rules of the Road workshop on Saturday if you guys are interested in that. It's virtual like this, but yeah.
all right, another question on, for the evening site. Are there lights on the pier or is that going to interfere with anything?
It shouldn't interfere, even if there's lights on the pier. You should still be able to see the star and the horizon.
Okay.
If it is dark out there, some people like using the headlamps or flashlights so you know when you're writing down
Yeah.
what it is, or you can read the sextant because our fancy plastic sextants, some sextants have a light that that has a light in here so it's easier to read, but if it's too dark you can't read that, so so you need a flashlight of sorts. So yeah, headlamps are good for that.
The MK or the Mark 25 sextants have supposedly have a light, but I've taken the batteries out because
that's this one?
I didn't know when. Yeah, so not that one. That's a 15.
Oh,
But the next, the ones that we've loaned out.
okay. Cool. Well, maybe you will have a light.
And is out
Definitely review.
because I didn't know when it'd be used again.
Review that worksheet or those PowerPoints of how to read a sextant. Just so we can practice that. But I'll be out there and it'll be fun. So our next Zoom though is a different link. So if you go to this link next Monday, I won't be there.
Right.
But
We can still get on to Google Classroom, right?
that's gonna stay up.
Okay. And that has the link to Zoom.
Yes. Yes.
Okay.
All right.
The
Well.
sextants from OCC.
Oh yes. Go on.
The sextants from OCC. If you want to change the eyepiece, there's instructions taped on the inside.
And you could, bring everything you have and ask questions and we can figure it out together. So we'll be good to go.
On how to change are inside the box.
All right, guys. Well, have a good one.
Good night. Thank you.
Okay.
Thanks, Bree.
Thanks,
Bye.
Bruce.